Okay, so in this video, I'm going to show those of you who are stuck or do not know how to do question 6 to question 12. Okay, so I'm going to guide you through, but I'm not going to show the answer. Okay, I'm just going to guide through with the workings and you guys will need to come up with the answer from the working. Okay, so let's start from question 6. Helium with a volume. Okay, so this is the volume 200 decimeter cube and I have the pressure 2 atm at the temperature of 28 degrees Celsius. It's to be placed into a tank, okay, with an internal pressure of this. Okay, so find what is the volume and this would be the new temperature. Okay, so as I've mentioned to you guys before, okay, how do you know you need to use a P1 V1 equals to P2 V2, V1 over T1 equals to V2 over T2, or you need to use PV equals to nRT. Okay, if there is a change, okay, just like this one, okay, placed into a tank. So it shows that there is a change in a new environment. Okay, so I'm giving it a new condition, a new surrounding. In this case, when there is a change, then I will be using before equals to after. Okay, so which includes either P1 V1 equals to P2 V2 or V1 over T1 equals to V2 over T2. Okay, or sometimes it could also be P1 over V1 equals to T1 equals to P2 over P2 times V2 over T2. Okay, so it depends on what are the variables, okay, what are this that I have. Okay, so looking from here, I could see that the temperature, they are the same. Okay, so since it is in a constant temperature, okay, so we can actually omit this from our calculation. Okay, also there is a hint here, okay, so it's a helium gas. I did not add in new gas. I did not remove any of the gases inside. So number of mole also remain constant. Okay, so that will leave us with volume and pressure. Okay, so let's rewrite what do we have. We have the initial volume is 200 decimeter cube. Initial pressure is 2 atm. Final volume, I need to find, okay, find the volume. And the final pressure is given in 600 kilopascal. Okay, so here since I only have P and V, hence definitely I'm going to use Boyle's law. P1 V1 equals to P2 V2. Okay, before and after. Okay, so here I will have P is 2 atm, V is 200. Okay, P2 600, V2 is what I need to find. Okay, again, as I always remind all of you, try to check the unit and make sure they are the same. So the volume is in decimeter cube, so this volume that I'm going to get will also be in decimeter cube. Okay, but here the pressure is in atm, this is in kilopascal. So it's telling me that I need to make sure that these two will have the same pressure before I can continue with this equation. Okay, so it's either we change the kilopascal to atm or we change the value of atm to kilopascal. Okay, it will be easier for me to do it this way because 1 atm equals to 101.3 kilopascal. Okay, so I'm going to times the atm with 101.3. Then you can solve this equation and you'll be able to get what is your V2 in decimeter cube. Okay, so for this, I'm going to leave you to solve since the working is already here. Okay, proceed to question number 7. Okay, calculate what is the volume that is occupied by, this is the mass of methane, okay, and then I have the pressure and I have the temperature. Okay, so as you can see here, there is no change in the condition. Okay, I have the P, I want to find the V. I have the mass. Whenever you have the mass, you know what is the compound. There is no problem for you to find the number of mole. Okay, so you have PVN RT. Okay, when there are no changes in the surrounding, in the environment, or in the condition, we will use PV equals to nRT. Okay, or let's say the question asks, given the condition, this pressure, this volume, with this temperature, okay, how many molecules are there? Okay, so it's in the same condition, the same given all the parameters, you need to find something from here. So you also use PV equals to nRT, the ideal gas law. Okay, and then as I mentioned, my R always double check, 8.314. I need to have in kilopascal, decimeter cube, Kelvin. Okay, so pressure in kilopascal, I can directly put in. Volume is what I need to find. Number of mole is mass over molar mass. Okay, methane, as I mentioned during tutorial yesterday, MEC, okay, 1 carbon, alkane, fully bonded. Okay, so it will be CH4. Okay, for methane, to those of you who don't memorize the formula, okay, so this is how you can at least know. Okay, so CH4, hence it will be 12 plus 4. Okay, and then R, you have 8.314. Temperature, remember you have to convert to Kelvin, so you add 273. Okay, then you will have the value of 327. Alright, okay, so from here you can solve and get your volume, and your volume will be in decimeter cube. Alright, so I'll leave it to you to solve this question as well. Moving on to question number 8. Okay, so the pressure. Okay, so this is the pressure exerted by, this is the number of mole, carbon monoxide in the volume, okay, of 10 decimeter cube. Calculate the temperature. I need to find the temperature. Give your answer to 3 significant figures. So again, there is no change in environment in this, no change in surrounding, no changes in the parameters. So we will be using PV equals to nRT. Okay, but whenever a question, okay, have things like this, make sure you highlight, okay, so that you remember to go back to the requirement of the question, because unlike physics, there are certain rule of thumb to follow, but in chemistry, if there is no special requirement like this in the question, it doesn't matter if you leave it in how many significant figures or how many decimal points. But if in the question it is written like this, you definitely will need to follow. Okay, so pressure, again, okay, R is 8.314. I'll be repeating this many times so that it's stuck on your mind. Pressure kilopascal, volume decimeter cube, temperature Kelvin. Okay, so pressure 120 kilopascal, so no conversion is needed. Volume decimeter cube, no conversion is needed. Number of mole 0.25, no conversion needed. R 8.314, and the temperature that I get will be in the unit of Kelvin. Okay, so as you can see, it's actually quite direct. Then you get what is the temperature in Kelvin. Okay, so since it's 3 significant figures, always remember to keep it in 3 significant figures. Okay, so I'll leave it to you to solve this as well. You can double check your answers. All the answers are given with the question. Okay, moving on next to question number 9. A gas syringe contains a volume of 42.3 centimeter cube. With this temperature, determine what is the volume, okay, that will occupy the syringe if temperature is decreased to this. Okay, so temperature is decreased. It shows that I am going to change the temperature. Okay, so when I'm going to change the temperature, that means I'm going to use an equation where before equals to after. Okay, and next I look at what are the parameters involved. I have V and T, V and T. So I know it will be V1 over T1 equals to V2 over T2. Okay, so before, okay, that means the original. So original volume is 42.3 divided by T1. Okay, remember T1, it doesn't matter, okay, for this, even though both the temperature are in degrees Celsius, you still need to change to Kelvin. Okay, it will always, for gas law, always the temperature has to be in Kelvin. Okay, so it will be 98.15 plus 273. Okay, so I leave it to you to calculate, and you need to calculate what is the volume at a new temperature. Okay, it's decreased to, so this minus is the temperature of the new substance, okay, of a new condition. So I will have to use negative 18.5 plus 273. Okay, and you can continue to cross multiply and get your volume. Okay, from here, since the V1 has a unit of centimeter cube, this has a unit of Kelvin, so this is also Kelvin. It's telling you that your V2 will be in the unit of centimeter cube. Okay, of course, if you want to convert from centimeter cube to decimeter cube, you are always welcome to do so, but you will have a different answer. Okay, so it's either 0.029 decimeter cube or it is 29.005 centimeter cube. Okay, both are acceptable if the question doesn't specify what unit you need to use. Okay, I'll leave it to you to solve this. Next, okay, question 10. An inflated balloon has a volume of 0.55 decimeter cube at sea level. So sea level will have this pressure, and it is allowed to rise to a height of 6.5 kilometer. Okay, so I have a balloon. It's allowed to rise, okay, to go up to a higher height, okay, of 6.5 km. It's going to rise up, where the pressure of the new height. Okay, so this one I have a pressure equals to 1 atm. So at a new height, my pressure is 0.4 atm. Assuming that the temperature remains constant, what is the final volume? Okay, so I'm doing changes to the gas, okay, to the balloon that contains gas. So there is a change in height. Okay, I have the initial volume, I have the initial pressure, and I allow it to float up. So this is the new pressure. What is the new volume? Okay, so since there are changes, I will use before equals to after. P1 V1 equals to P2 V2. Okay, so P1 is 1 atm, V1 is 0.55 decimeter cube, P2, okay, atm, so I can equivalent, no conversion is needed. And next, V2 volume. Okay, so it's telling me that my volume will be in the unit of decimeter cube. Okay, so can solve according to this. Alright, so moving on to the two questions from the last part, okay, where I have a mass of liquid X was vaporized at temperature 100 degrees Celsius. I will form, okay, a volume, okay, of 23 centimeter cube of vapor. The pressure is this. So calculate what is the relative molecular mass of liquid X. Okay, again, I have a special requirement of the question, so I'll keep it highlighted. Okay, so here I'm given a condition, okay, I give you the mass, I give you temperature, I give you volume, I give you pressure, I want to find relative molecular mass. So this is from the derivation, okay, where PV equals to nRT, and we know number of mole will have the formula mass over molar mass. Okay, so I can also write it as mass over molar mass times R times T PV. Since we want to find molar mass, okay, I believe we gone through this in the lecture slides, but don't worry, you do not need to memorize this new formula because this is actually in your brain already. So you can actually derive on the spot during the exam. Okay, as long as you know number of mole is mass over molar mass. Okay, so just rearrange this. So molar mass will be mass times R times T divided by P times V. Okay, so this is after I rearrange the formula, I will get this new formula for me to calculate molar mass. So I just put in this formula. So molar mass equals to M times R times T divided by P times V. Okay, I need to make sure that all my values are correct. So I'm going to use 8.314 again, volume in decimeter cube, pressure in kilopascal, temperature in Kelvin. So volume here is in centimeter cube. So from centimeter cube, I want to convert to decimeter cube, I divide by 1000. Okay, let me rewrite this. Sorry, not enough space. Okay, meanwhile for pressure, okay, I hope you remember your conversion from your physics, okay, as well as I did roughly mention this yesterday. Pressure has to be in kilopascal, okay, this is in pascal. So you know that your kilo is actually 10 to the power of 3. So as you put out, okay, you take out 10 to the power of 3, so it's left with 1 times 10 to the power of 2. Okay, because you have already taken out 10 to the power of 3 for your kilo, so you are left with 10 to the power of 2. Okay, so if you times together, then you are going to get 102 kilopascal. Okay, so this conversion, I hope you'll be able to do this. And lastly, temperature, this is volume, this is pressure. Temperature, you need to convert to Kelvin, so it's 100 degrees Celsius plus 273, you will get 373 Kelvin. Okay, so now you can substitute inside this equation. So molar mass is mass, it will be in gram. R is 8.314, temperature is 373 divided by P 102 kilopascal times V 0.023 decimeter cube. Okay, since it's asking for relative molecular mass, all right, so relative molecular mass, it does not have unit. Okay, so it's only the value. Okay, it does not have unit. Remember to keep it in 3 significant figure. Okay, molar mass has a unit of gram per decimeter, molar mass has a unit of gram per mole. Okay, each 1 mole of the substance will be this mass. Meanwhile, relative molecular mass has no unit. Alright. Okay, so moving on to question 12, which is similar to question 11. I have the mass. This is the volume. This is the temperature and this is the pressure. Calculate the relative molecular mass. Okay, from the derivation just now, I know that relative molecular mass is mass times R times T divided by P times V. Okay, so let's do the needed conversion. Volume 81.8 centimeter cube. I need to change to decimeter cube, so divide by 1000. I will get 0.0818 decimeter cube. Next, pressure 1 atm. I need to convert to kilopascal, so 1 atm equals to 101.3 kilopascal. Okay, again, as I mentioned, okay, if you have been doing this many times enough, okay, you will remember this. Okay, so just 1 times 101.3, so you will get 101.3 kilopascal. And temperature, okay, 127 degrees Celsius plus, okay, you need to convert to Kelvin. So you add here, you will get 400 Kelvin. Okay. Okay, then you can substitute the value. Mass is 0.112, R is 8.314, temperature is 400, divided by pressure is 101.3, volume is 0.0818. Again, okay, you will be getting an answer which does not have any unit because it is relative molecular mass. Okay, relative is I'm comparing the mass to 1/12 carbon 12. So since it's comparison, the unit cancel off. Okay, so I don't have a unit here. All right. Okay, so that's all the examples that I didn't have. I leave it to you, okay, to do as homework. And since none of you asked questions about these few questions, so I'll just leave this here. In case, okay, you guys are stuck but you didn't voice out or you are afraid to voice out, at least this can serve, okay, as a platform for you to know where to start going. But you always have to know, okay, by looking at me doing it, it seems very easy. It seems logical, it seems understandable, but you definitely will have to try on your own. Okay, because in the exam, I will not be there to guide you how to start. So you need to start doing exercises on your own to know the type of questions, okay, the pattern of the question and how to get started. Okay, that's all for today. So I'll end this here. Thank you very much.